Welcome to my presentation. Today we're going to be talking about disruptive innovations, particularly SmallSats. So, satellite technology isn't new. It involves beaming internet data through radio signals through the vacuum of space instead of through cables. Ground stations on the planet broadcast the signals to satellites in orbit, which can then relay the data back to users on Earth through the use of transponders. While there's no official or established standard for a small satellite, the term SmallSats typically refers to a spacecraft with a mass of less than 500 kilograms, while the threshold tends to vary across certain players in the industry. Artificial satellites vary in size and cost depending on the use that they're put to. They can be small enough to fit in the palm of your hand, or they can be as huge as the ISS. According to NASA, there are a variety of small satellite types according to mass, including mini-satellites, microsatellites, and nanosatellites. So SmallSats are significantly more cost-effective than larger spacecraft, and they're easier to produce due to their cost-efficient manufacturing process, making them best suited for constellations. Constellations are groups of satellites working together as a team, enabling new technologies and applications, including GPS and internet services. Without the access to frequent images and information collected through our constellations of SmallSats, we could not be able to identify, analyze, and deliver timely insights. Satellite internet businesses are looking to improve the technology primarily through using low-orbit satellites that circle the Earth, which typically operate from 500 to 2,000 kilometers above the Earth's surface, which can improve internet speed. Traditional communication satellites are stationed far higher at roughly 36,000 kilometers and travel in so-called geosynchronous orbits, meaning that they move at the speed of the Earth's rotation. LEO satellites provide a faster trip so that the time needed for data to be sent and returned, what's known as latency, is lower for LEO satellites than for those that are farther out. In the past 5 years, the space sector has grown more than six-fold, with new technology satellite manufacturers appearing since 2005. And there are three aspects of today's business world that are driving that level of investment, such as heavy data use, the need for stronger data security, and the demand for ever faster communications and processing. So how fast one can respond to customers and their needs has become a critical differentiator among competitors. Several firms have been set up or announced plans to launch satellites into orbit to expand internet access worldwide. For example, OneWeb, a London-based company, has been launching washing machine-sized LEO satellites recording an average latency of 32 milliseconds in July 2019. SpaceX, which operates the world's largest satellite constellation, is aiming for a latency of 20 milliseconds initially. Until recently, prohibitive costs associated with the industry has served as a barrier to entry, with the combined cost of building and launching satellites themselves often exceeding the $1 billion mark. However, SmallSat disruptors' success will depend on their ability to optimize their supply chain strategy. Companies have to ensure distinctive, hard-to-replicate resources and capabilities that existing firms have developed. These resources, made up of integrated combinations of assets and capabilities, are cultivated slowly over time. The incumbent space industry firms possess strong outside-in capabilities in design, testing, and manufacturing, as well as the technology development and transformation processes required to build large satellites for institutional customers. At present, there are no substantially reliable small launchers on the market. This means that companies that wish to launch SmallSats are dependent on existing large satellite launchers, forcing them to collaborate with incumbent firms. While a lot of excitement surrounds the new breed of space startups, SmallSat disruptors need to identify which of their distinct capabilities have the potential to generate value, as well as to develop the new capabilities necessary to capitalize on emerging opportunities. Some emerging threats include the possibility of space becoming too crowded, potentially causing collisions that trigger a wide reaction of debris. Additionally, as more satellites are deployed, regulations around deployment rates, frequency allocation, and/or orbital debris mitigation are likely to be modified. So companies that can better manage these disputes may gain a better competitive advantage. So these and other actions hold tremendous value and promise to capture the potential of the small satellite revolution and ultimately to advance our knowledge and understanding of our own world and the far reaches of space. Thank you so much, and I look forward to connecting with you guys soon.